So if you turn to page 4 in your 3B packet, you see the title of odd function. Now, as you have seen in my previous videos, an odd function is one that is symmetric with respect to the origin. So if you were to rotate the function 180 degrees around the origin, it would give you the same exact picture on the graph. So the example on your notes here is the example of f of x equals x cubed. Now, we're going to jump down here into testing if a function is odd. So when a function was even, I'm going to zoom in for you. When a function was even, let's just recall, that meant that f of negative x equaled f of x. When a function is odd, however, we use f of negative x is not equal to f of x. It's equal to negative f of x. So we're going to take a look below to see the different outcomes that are going to come up. So I always start a problem like this by starting with f of negative x, because you notice f of negative x is in both of these. Regardless of if I'm testing for even or odd, I need to figure out what f of negative x is. So I'm going to go to example 4. F of negative x would be negative x squared minus 2 times negative x plus 4. Notice I've replaced the x's with negative x. Now, negative x squared, because I have a negative to an even power, that's going to be x squared. Negative 2 times negative x turns out to be plus 2x, and then I have plus 4 on the end. Now, we can tell that this is not going to be even because x squared plus 2x plus 4 is not the same as x squared minus 2x plus 4. So this automatically tells me not even. So once I check to see if it's even, now I go forward and I'm going to check to see if it's odd instead. So in order to check if it's odd, I'm going to see this here, if f of negative x is equal to negative f of x. So negative f of x means I'm multiplying f of x by a negative 1. So I have negative 1 times f of x. So x squared minus 2x plus 4. Now if I multiply that through, I get negative x squared plus 2x minus 4. So now I'm checking, is negative f of x equal to f of negative x? Negative x squared plus 2x minus 4 is not the same as x squared plus 2x minus 4. So between these, that means it is not odd. So a function is going to either be even, odd, or neither. And this one is neither. So let's check example 5. So again, first thing I'm going to do is f of negative x. Plug in negative x, so that would be 2 times negative x cubed minus 4 times negative x. Now keep in mind, negative x to the third is going to come out negative because of the odd exponent. So this first part is going to end up being negative 2x cubed. And then this would end up being plus 4x. So right off the bat, I can tell that this is not even because f of negative x, negative 2x cubed plus 4x, is not the same as 2x cubed minus 4x. So right here, I can say it's not even. Now I'm going to check negative f of x, which means I am going to multiply -1 by the function. If I distribute that, I end up with -2x cubed plus 4x. Now notice these two, f of negative x is -2x cubed plus 4x, and negative f of x is -2x cubed plus 4x. So since f of negative x equals negative f of x, that tells me this is odd. And that's our conclusion. So what's really tricky with these is honestly just the smaller algebraic processes. Like this up here, -x cubed. This is like a -1 times x cubed because the negative remains. And that's why that became -2x cubed. Those minor details of a negative x to a power becoming positive or negative, that's what really throws people. So you need to make sure you're checking even or odd exponents really go a long way in recognizing if things are going to be positive or negative. So just as a step-by-step process, it says check if f of negative x equals f of x. So the first thing you really do is you find f of negative x. If that gets you nowhere, meaning if it's not odd, even, sorry, if you find f of negative x and it's equal to the original, that would make it even. If that doesn't get you anywhere, then step 2 is to find negative f of x. So first you check if it's even, then you check if it's odd, and if neither of those work out, then it's neither.